Welcome to another session. In this video and in the coming two videos, you will be learning how to do object-oriented programming with Python. In this video, we will be looking into the concept of objects and classes. So at the end of this lecture, you should be able to analyze a problem and decompose it into programmable objects. To begin with, let's do a simple activity. We are going to simulate a computer game. I hope you all are familiar with some sort of computer game. Let's read the description shown in the next three slides. Your first task is to identify the entities mentioned in that description. Here, entities mean living and non-living things. In the center of the land of Mordor is Mount Doom. The challenge is to climb to the top of Mount Doom. Whoever reaches there becomes the winner. A set of warriors go climbing this mountain. Each warrior has a walking stick. The walking stick helps the warrior walk. There are monsters in the land of Mordor. Some monsters are innocent. They will steal the warrior's walking stick. But other monsters will kill the warrior and take the walking stick. If a warrior loses the stick, that warrior is trapped. In the land of Mordor, there are magic trees. If warriors eat the fruit of these trees, they become immortal. The warriors are also of two types, super warriors and normal warriors. Each super warrior has a pair of binoculars. They can look for any magic trees in the area. Normal warriors cannot see a tree unless they bump into one. Here you can see all the entities that we identify. Land of Mordor, Mount Doom, warriors which can be of super warriors and normal warriors, walking stick, monsters, magic trees, fruit and binoculars. This is exactly what we do in object-oriented programming. We break down a programmer task into objects. Here, objects are none other than the entities we mentioned earlier. These objects have behavior, like the monster being able to steal the warrior's walking stick, and properties, for example, the binoculars of the super warrior. In object-oriented programming, the behavior of objects are specified via methods, and properties are usually referred to as attributes. So, in this simple game we discussed, our objects refer to warrior, monster, fruit, etc. All these effectively represent concepts in the real world. As another example, we can have an object representing an employee in a company. There have to be multiple objects, each corresponding to an employee. An employee object handles the processing of and data management related to the corresponding employee in the company. So, what are the objects in our gaming simulation when it is running? There can be multiple warrior objects, multiple monster objects, multiple tree objects, likewise. As I mentioned earlier, an object has a set of attributes which collectively define its characteristics. The values of these attributes at a given point in time determine the status of the object or the object state. As a new example, consider an object referring to a bank account. It has a unique number, the account holder's name, and the current balance. The account number or the account holder's name may remain the same throughout. However, the current balance changes often. So, if we consider the state of a bank account object including these three attributes, at different time points, the object may be in different states if the bank balance has different values throughout. In our gaming simulation, we have multiple warriors and monsters. Similarly, in a company, there are multiple employees. And in a bank, there are multiple bank accounts. So, as you can see, in all these cases, there is more than one object from each type. For example, the objects of a particular type have the same set of attributes. What differs is the actual values of these attributes. For example, one warrior's name can be Frado, while the other's name is Sam. Similarly, Peter's bank account may have $500, while Anne's account having $1,000. To create different objects of the same type, we use a blueprint called a class. A class specifies what attributes and methods its objects can have. When creating objects from a class, we provide actual values for the attributes specified by the class. That way, we can create any number of objects from the same class. You see an example here. We have a bank account class. From that, we have created three different objects. One corresponding to John's bank account, the other referring to Bill's bank account, and the third one referring to Mary's account. They all have an attribute referring to the account balance. However, different objects have different values for this attribute. Let's look a bit deeper into the attributes and methods. As mentioned earlier, attributes refer to the current state of an object. Together, attributes refer to the characteristics of an object. These attributes can be simple or complex. Simple attributes are primitive data types such as integer or boolean. Complex attributes can contain collections or data structures of either primitive or complex objects. For example, an array of integers is a complex attribute. Similarly, if an attribute references an object of another class, this attribute is also considered a complex attribute. As mentioned earlier, methods of an object define the behavior of that object. One object can invoke or execute method of another object. For example, as shown here, a monster object can steal the walking stick of a warrior object by invoking the loose stick method of the warrior. Invoking methods is kind of a message passing between objects. Now you can try out a simple exercise. Think of an object. Try to determine the class it belongs to, its attributes and methods. For example, I am considering a pencil. So I am referring to this pencil in my hand. It is different from the pencil you are holding. Actually, I have more than one pencil. So each of these pencils refer to a unique object. They are all belonging to the pencil class. However, they have a color attribute, but each pencil has a different value for this color attribute. This one is having the attribute value blue and this one having attribute value peach. And a pencil can have a method write. Okay, now we want to create objects of different types. To do that, we need to identify the set of classes we need. How can we identify the set of classes from a given scenario? One option is to look for the nouns mentioned in the scenario. However, this can be misleading sometimes because attributes are also nouns. So, instead of simply looking for nouns, we can look for nouns that are interacting with each other. To identify verb behavior, we can look for verbs. To better understand this, refer to the first part of the gaming scenario. Here, the warriors climb Mount Doom. So there is an interaction between the warrior and Mount Doom. Thus, both can be considered as objects. Monster steals the warrior's walking stick. So there is an interaction between the warrior and monster. Therefore, both are objects. How about walking stick? Is it a property or an attribute of the warrior? Or in other words, is it referring to an object or just a primitive variable? Since the walking stick helps the warrior walk, we can consider the walking stick an object. Thus, walking stick property of the warrior can be considered a complex object that refers to a walking stick object. When we implement the program to simulate the game, we know we need classes for warriors, monsters, etc. Okay, now we know that we need a class to create objects. How exactly are we going to create objects from a class? We are going to learn that now. First of all, a class has to have a constructor. When the constructor is called, it creates an object. In other words, a constructor constructs objects. You would remember that with attributes would be there for its objects. How can we specify values for these attributes? When objects are created, we can get the constructor to set the values of the attributes. Here is a sample class, monster. We need to use the special keyword class to indicate that we are writing the code of a class. This is required because, as you know, so far, as you learned so far, in Python, you can write code statements that are not included in a class. The color variable shown here is considered as a class attribute. All the monster objects will have the color attribute set to black. In contrast, agent name attributes are specified along with the self keyword. This means these are instance attributes. That means different monster objects will have different values for agent name attributes. Note that we do not have to specify the type of the variables as Python has dynamic typing. Methods of a class are also marked by the def keyword. The special init function that has leading and trailing underscore is the constructor here. Here we are passing two parameters, age and name, to the constructor. They are used to set the values of the instance variables age and name of this class. Note that these methods have the same first parameter as self. It is a keyword used to refer to the current object. We do not have to pass a self parameter when calling these methods. It is automatically included. By default, attributes inside a class, both class and instance attributes, can be accessed by any other class. That means from any other place in your Python code. However, by convention, private attributes are defined using a leading underscore, such as the isInnocent variable here. It is a good Python programming practice not to access such variables from other classes. Here we can see how we can call the constructor to create monster objects. As you can see, using the same class, we have created two monster objects, monster1 and monster2. They have the same instance attributes, but the values are different. In contrast, they will have the same value black for the color variable, which is a class attribute. Note that we can set or change object attributes even after creating that object. For example, monster1.age.10 sets the age of the monster1 object to 10. You are welcome to try out this code and try different alterations. Here are different ways how you can use constructors within a class. As shown in the first example here, you can get all the parameter values from outside, meaning that when the constructor is called, we have to give the parameter values within the brackets. If you want, you can specify your default values for some of the parameters, as shown in the constructor 2. In this case, it is not mandatory to specify the parameter values when calling the constructor or the method. In fact, constructor 2 and 3 are doing the same thing, using default values in the attributes. However, constructor 2 is more useful, since it also allows setting the attributes values if needed. Note that it is not mandatory that we add a constructor to a class. If no constructor is defined for a class, a superclass constructor is used to initialize objects. We will learn about superclasses in the next lecture. Note that method parameters are passed by reference. For example, in this first instance method, we receive a warrior object as the parameter. When you set its age, value of this age attribute of this warrior object will be visible to every other place that uses the same warrior object. Similar to functions you learn in course 1 functions lesson, methods perform some tasks and return a value or a set of values. However, there are a few key differences between methods and functions. We define methods inside a class, but we can define a function even without any class. An instance method is associated with the objects of the class it belongs to, whereas a function is not associated with any object. Also, an instance method can operate on the arguments passed on to it and the attributes of the associated object. See the second instance method that belongs to the warrior class. Here, the number of sticks is an instance attribute defined in the monster class. In contrast, a function cannot operate on attributes associated with an object unless the object is passed as an argument to that function. In addition to instance methods, a class can have class methods and static methods. A class method receives the class as an implicit first argument and can change the state of the class, which will affect all the instances that have been created from that class. In contrast, a static method does not receive the class state of the contrast, a static method does not receive the class as an implicit first argument. Static methods are used as utility functions, for example, to do some simple calculations. More details about these methods are given in lecture notes. In summary, we learned how Python could be used in an object-oriented manner. Object-oriented programming models solutions to problems using a set of interacting objects. An object has a state defined by the values assigned to its attributes and behavior. We use classes to define the attributes and methods of a set of objects of the same type. Thus, the class acts as a blueprint. We can create objects by calling the constructor of the class. We learn various ways of using constructors as well as methods. In the next lesson, we will learn about the fundamental principles of object-oriented programming and how these are implemented in Python. Thank you very much.